Thank you so much for you all for coming and joining online. I wish I'd prepared something now. So, as ever, this is the Slido code, so you can ask me questions at any point or tell me where I've gone wrong. Welcome to the last of this lecture series, The Nature of Music, and thank you for joining me through it all. Through this lecture series, we have traveled across the temporal spectrum to find where music exists in the audible spectrum, how it's transmitted and broadcast in the electromagnetic spectrum, how rhythm works, and even turns the motion of the planets into music. But here we'll go further to the very edges of time and see where music intersects with infinity.
Will we ever be able to see beyond the current observable universe?
Oh, it's much worse than that. The observable universe is shrinking.
If you want to know what are my odds of winning the lottery, you come straight to probability.
Yeah.
Because probability is all about how likely or not events are to happen.
I think the chance of there being an undiscovered second species, very like humans, out there in the world today is pretty slender. However,
and these are the pictures if you haven't seen them. I mean, New York was orange. The air was orange. They said one day out in that air was like smoking a pack of cigarettes. It had the same effect on the lungs as smoking a number of cigarettes. So people who'd never smoked in their life were suddenly going to suffer some of the same health effects.
Any Further Questions is a brand new podcast from Gresham College, a place where we ask our speakers all of your questions that went unanswered following their lecture. Guests have included Ronald Hutton, Robin May, Chris Lintott, Sarah Hart, and Maggie Snowling. Any Further Questions, all episodes are available wherever you listen to your podcasts.
Now, Chris Lintott, my colleague, tells me that if you ever have a talk with a question in the title, the answer is always no. So we'll take that approach first and see why music might be a non-renewable resource. And there has been, throughout every generation, this pessimistic view that we're running out of music, and all the good music has already happened. And if we want evidence, we can point to it. For example, take this tune by James Brown, I Got You, probably the start of dance music, and notice how the tempo fluctuates throughout. There's a fluidity. But then in the early 70s, for convenience, click tracks were used. Now have a look at what the tunes did at that point. Literally flatlining music. There is also evidence for a lyrical stasis and exhaustion. In this huge data set of songs, they found that lyrics became simpler in terms of vocabulary richness, readability, complexity, and the number of repeated lines. Basically everything. Now, it's easy to find cherry-picked examples. So let's take this. Good title to start with. Simple words, but they carry with them a story, a meaning that haunts, that lingers in the imagination. Let's compare it with a contemporary piece by Dr. Bieber. It starts like this. Yeah, you got that yummy yum. That yummy yum. That yummy yummy. It goes on. Yeah, you got that yummy yum. That yummy yum. That yummy yummy. There's also evidence of stasis when it comes to harmony. Take these four fundamental chords that come from a major key, the 1, 6, 4, and 5. They each have a sort of status as distance from home. 1 and 6 are kind of like tonic chords, 4 is the subdominant, 5 is the dominant. So in this order, they create a sort of ridge of tension that falls away in the classic 5-1 cadence. And this was used for quite a long time from the 50s onwards as a tool for writing pop songs, such as this example here. lift and drop. Lift.
Earth angel, earth angel.
But we grew tired of that sawtooth-like tension, all these 5 ones, and we felt, for some reason, that softer movements were necessary to invite repetition. So by moving the 5 chord here, what you create is 2 plagal cadences, removing that dominant, and 2 of these softer cadences called a deceptive cadence and a leading tone cadence, which invites repetition, a sort of smooth surface. It started with this tune, Any Way You Want It by Journey, and you can hear that compelling flat harmony. I'll wait for one more repetition. But it can go on forever. In fact, there's been a feeding frenzy on this one loop. Here's a partial list. No need to memorize it. Using this sequence. But because it's a loop with no real start point, it actually invites different cyclical patterns. We can loop the loop, not start on the 1, but start here. Don't believe me? Listen to this.
Hello from the other side. I must have called 1,000 times to tell you I'm sorry.
How many tunes use this? Well, this many, a partial list. Those are the 2 tonic starting points, but we can start here.
My shadow's only one that walks beside me.
I like
My shadow, I'd say.
Here's a partial list. And finally, we're doing the unthinkable, starting on the 5 chord. The least common, but still useful.
To bring our neighbors home from war. They would have never missed a Christmas. No more ribbons on their door. And when you trust your
I'm not saying I don't like it. Here's some tunes that do that. In fact, it's almost like we're circling this harmonic drain. And you could almost put all of these tunes together, put them in the same key, displace them appropriately, and have a pop soup. This is 17 tunes on that circle at the same time. You might recognize a couple. So pitch transition has homogenized, as has timbre. Here's a nice quote. There's a generic usage of pitch, timbre, and loudness. These point towards less variety and consistent homogenization towards louder and potentially poorer volume dynamics. Not a good review. So it makes us ache for the past. But again, we have something that might be called a nostalgic regress. We think of these tunes like this one as the original good tunes, sung by Michael Jackson. But not written and sung by Michael Jackson, but by the Yorkshireman Mick Jackson, who co-wrote and sang it first. No relation.
Spent the night in Frisco, went to every kind of disco. And from that night I kissed our love goodbye. Don't blame it on the sunshine.
A tune I happen to love, 1981's
Miss you.
It Must Be Love.
As I do.
Lovely is actually a reworking of an even lovelier tune.
And I never thought I'd feel this
Same
way.
key as well.
The way I feel about you.
Not to be outdone, Procol Harum, in a whiter shade of pale,
Turns cartwheels across the floor.
did a 230-year cover of Bach. I've merged the two here.
We skip the light fandango.
So that's stasis. But even when there's progression, there could be something that could be termed a dead end. For example, in rock and its associated styles, there's been this push to have more distorted guitar sounds, more weighty and drop tunes, guitars. And this contour of pitch against distortion spells out various rock and metal subtypes, or elements, I guess. So we start in the apparently rebellious, but now quaint 50s, with the low A and the slightly broken sound.
When the chimes ring 5, 6, and 7, we'll be right inside.
How rebellious. And then to the wonderful proto-rock of Sister Rosetta Tharpe, a bit more crunchy. A little more saturated in the 60s. Low E. That's not good enough. Let's go down to an E flat, add a bit more fuzz. Or down to a D, perhaps. Let's have these a little louder, please. Here we add more distortion into the mix. We'll keep a D, but now we'll really rev up that distortion. Come on. Where do we go from here? Down. Yes. You like it? Come on. Let's go more distorted and lower with this drop B. Come on. Oh. Drop A now. We're infiltrating the bass guitar's territory. Poor Bill Haley. And the appropriately named Humanity's Last Breath have a drop E, which is the same pitch as a bass guitar, and morbid distortion. Where do we go? Well, double drop E, an octave below the bass, which can hardly be heard. Here's one note of it with a lot of distortion, so you'll hear the upper partials. It's like we've run out of things to do with the guitar in terms of heaviness. Maybe we can remove the neck entirely and so that's the case for musical exhaustion. Let's be more positive now, because music also, when we hear it, gives a sense of endlessness, both in space and time. Here are some quotes from you, from this Gresham survey, about the sense of limitlessness and temporal detachment and moving away from the body. And this is why we listen to music, it's as if it escapes time. And in fact, time is written into the fabric of music. We can start with a musical symbol of duration and split it again and again and again into the canto dust of time. And we can do this indefinitely, beyond our perception. Composers, of course, abuse this sort of privilege. Here's Heinrich's 1825 piece. Look at this passage here. It's absolutely ridiculous. These are 2048th notes. And if you're keeping score, those are demi, semi, hemi, demi, semi, hemi, demi, semi quavers. Yes, an apology is due. How does that sound at a very, very slow tempo? let's listen to these. I couldn't get it short enough, the reverb, just reverb there. So music can slice time indefinitely, but it also wraps time around itself. Now it's possible to conceive of music that lasts forever. In response to a criticism about my music being too repetitive, I wrote a provably non-repetitive piece based on irrational numbers, which, without repetition, could last forever. But we don't have forever to listen to music. Music seems to trick us into believing it lasts forever, with tools like this: repeat signs, random access to different parts of the piece, and even fading and fading out, which suggest an endlessness or a very lazy arrangement. Electronic music have harnessed these massively by using feedback and even the possibility of freezing sound forever. But it goes further back. Composers have abused this ability to repeat. The always eccentric Eric Satie has this piece here. Notice he removes the bar lines because he didn't like the sense of that rigid structure. And he asked the pianist to play it 840 times with some really helpful suggestions of how you should prepare yourself beforehand. I feel like that sometimes. But that idea of circling time is actually ancient. It goes back to the Makam and this beautiful 15th century piece. Look at this score written in circle notation, which allows both the performers and the listeners to be caught for a moment in the sense of infinite time. But music isn't just time, it has structures like pitches and scales and harmony, which allows all sorts of cycles to occur. The most common one is the idea that we hear in terms of horizontal line, but also there's this idea of octave equivalence in many music cultures, where notes an octave apart are somehow the same. We come back to where we start. And if there's one optical illusion which does such a thing, it's the Shepard tone, which endlessly rises. Well, it's not endless. It takes pitches and they keep going up until they reach the octave and then they fade out. And we just connect them together by virtue of our predilection to hear line and octave equivalence. Here's a visual and auditory demonstration. I'll tell you when the loop starts. Here. And here. Still gets me. And musicians capture this, not just in long lines, but in notes. Take this canon by the ever-ingenious J.S. Bach. It's one of his puzzle canons based on a theme that was given to him, the royal theme. It's this knotty, almost impossible to manage theme, but he creates these endless, beautiful reconfigurations of them. And one of them is this canon at 2. Now, it doesn't look like much, just a handful of bars, but within it, you have to sort of decode it. What you have is one voice that is a canon. It's played against itself a fifth apart. That's just standard brilliance from Bach. But the clever thing is the melody, which starts in the key of C minor and then creeps up to the key of D minor and keeps repeating this process. We can hear the key modulation. So I'll just take the first bar from every repetition, so you get a sense of it. And if we go up in whole tones, we'll eventually come back to where we started. And he says in the inscription, as the melody rises, so does the glory of the king. What a suck-up, but a brilliant composer. So I like to think of this piece as endless staircases. One of those 8 bars that repeat over and over again, and another slower loop of modulations that slowly creep up. And they're not like Eurovision modulations, which suddenly happen. It's written in such a way that, like a Shepard tone, you don't hear the seams. What you'll hear is the red cursor go round 8 bars, and then when it comes back to where it starts, we'll get the theme again, but a tone higher. Here's the repetition right here. And we're in D minor. How the hell did that happen? And musicians are masters of these loops. Here's something from the quiet genius with infinity in his mind, Schubert. This passage here in green. We'll just be coming up to it. It'll go by quickly, but just so you get a sense of it. That's it. Seems like this pretty elegant ornamental thing, but it's absolutely ingenious. What's happening here is that Schubert starts on D minor, and then he moves to F, which means it's only one note that changes. In fact, only one note is changed at every transition. It's a smoothly voice-led pattern. So he goes from D minor to F to A minor to C, C minor, until he gets back to D minor without retracing his steps. How is this possible? And it's possible because of the many loops that coexist in musical structures. We all might know the cycle of fifths, where if you start on one note, you can go up fifths and come back to where you started again. But there is also other cycles, like the cycle of major thirds. This is only 3 notes long, C, E, G sharp, or A flat, and back to C. This is in a 12-tone universe, of course. Or the cycle of minor thirds, which is 4 long. And these are all happening at the same time, and they intersect in strange ways, creating chords along the way. And also, notes reappear at various other points in this lattice. You might remember this from the last lecture as Euler's tonnets here, but I kept it simple for you that time. This surface of chords actually wraps round in extraordinary ways, and the best way to present it is not in 2 dimensions, but in 3. How do we wrap a 12 and a 4 and a 3 around so they connect? The answer is obvious and delicious. It's a donut shape. This is how we wrap all the 24 triads together. And Schubert, ingeniously, does a nice little icing, frosting of this donut around here. I'll show it in slow motion. So remember that every move only changes 1 note. So we should see it creeping along the tonnets and around the bagel or donut, whatever you've had, depending on what you've had for breakfast. So let's go. And back to D minor. Let's hear it in context to see how fast and elegant, and he continues on in this elegant dance. We can also think about musical completion or infinity in terms of collections of musical objects. And humanity has always had this desire to catalogue, collect, identify, name objects. And it's no different when it comes to music. This is ancient, particularly in Arabic maqam. And this is a collection of rhythms. And they're rhythms actually which are sourced from Arabic poetry. So they have a very prosodic nature to it. They sound like speech. In fact, they're only built up from 3 objects: a dum, a tak, and silence. So this one here, the maxim, which actually appeared in lecture number 2, is dum tak, tak dum tak. See if you can hear it in this passage. Dum tak, tak, dum tak, space. Space matters. It's more than a meter, it's a sort of phrase quality. There are many, many in this catalogue. Here's a really beautiful one. Darafat here. So it would be dum, tak, dum, 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 tak. 2, 3, dum. Go up to 48 beats and beyond. In the Western tradition, it was inevitable, perhaps, that cataloguers would try and collect themes, particularly classical themes. In this wonderfully positive book, A Dictionary of Musical Themes, there are 10,000. This is pre-digital era, so they had to do this manually. And how would you look up a melody? Well, you would hum it to yourself, and then there's this huge index that starts with C, 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 C sharp, and so on, until you found your melody. You're all assumed in the key of C. And then you would look up this catalogue number M863, and you would have the music emerging from it. This is still used in copyright cases. Now, both of those are quite partial. They're sort of looking outward to what exists in music and then cataloguing it. But there's an idea of a musical set which starts kind of from the ground up. We can think of starting from nothing, and we saw this in the last lecture, thinking of the 12 notes as a necklace or a bracelet, and deciding which ones are on and off. That's it. And Alan Forte, who might have had fewer friends than me, spent a long time cataloguing them and naming every single one of these objects. Not very beautiful names, but naming them nonetheless. The pentatonic scale, or the vulture bone flute, if you remember that, is 535 and has this shape to it. And everything from silence, which is 0-1, which is basically means it has no notes in it, and it's number 1 on the list with no notes in it, all the way up to the chromatic scale, 12-1. And in the middle, the Hendrix chord, which is given the rather astronomical name 4Z15B. Chris Lintott would be proud of that one. Another approach to not just creating chords and objects, but melodies or scales, was by this chap, Slonimsky. I knew I wouldn't say that the first time. He's extraordinary, as you can tell by the company he keeps. That's him with Zappa, in a Mobius strip of music with John Cage, and a dedication from Leonard Bernstein to him. He published lots of really beautiful material. Last lecture, we saw his Lexicon of Musical Invective, which is a collection of terrible reviews of great composers over the time. But he's most famous, perhaps, for this, Thesaurus of Scales and Melodic Patterns. And it is a sort of ground-up collection of materials. And I'll give you some of the mechanisms that are used within it. Most people give up by page 2, but we'll go a little bit further. The nice thing about it is that you start not with a triad or a major scale, but you start with absolutely nothing. A universe of nothing. And then just one note. You pick a note. I'll play it for you, just in case you don't know what note is. There it is. And then you take not just a note, but like a two-dimensional space. You take that beginning note and the end note. Let's make it an octave, but you could take whatever space you like. And then we have this. Now we can divide that space up in as many parts as we want, equal parts, unequal parts, but he starts with divided in 2 equal parts. So we have these principal tones that exist here. Not much, but it's a start. But the thing is, all the moves are quite systematic. So he takes these principal tones, and then he has these devices that color, that ornament. So one of the tools is interpolation, adding one note above that principal tone, just a semitone above. So we have this. We need new fun terms. So this is interultrapolation, one note above, the starting note, one note above the next one. Don't worry, there's no test here, but you get the idea. Interultrapolation. I managed that, but not Slonimsky. Sounds like this. And then you start creating, kind of from thin air, something that resembles music. A strange music, but a sort of life. I like it. And the Thesaurus goes on, creating all these strange beasts. Some of them that exist out in the universe, but many that only exist in that Thesaurus. One very beautiful one is the so-called grandmother chord. It's like no grandmother I know, but it's a lovely chord. What it is every 12 notes arranged in such a way so that all the intervals, all 11 intervals are present, but they are presented in a palindromic fashion. And if you don't understand what I just said, just remember, it's clever and it sounds cool. There you go. And along the way, you have these patterns which start to sound quite familiar. Why that sounds familiar is because of one person, and that is John Coltrane, who after his amazing exhaustion, perhaps, of standard jazz, continued on this mission to create a jazz that was more open-ended, not held back by harmonic structure, but sort of hinted at the infinite possibilities of musical realization. Listen to lines like this, and you'll hear ghosts of Slonimsky in his reasoning. And throughout his compositions, like the famous Giant Steps, which itself is a fractal loop. There are 3 key areas, a major third apart, so it's one of those loops. They appear every bar, but that same pattern every 4 bars also. Self-similarity, a fractal. And that on the left is his diagram. He wasn't guessing this, he was constructing it from the ground up in a beautiful fashion. And as his career and his spiritual depth, let's say, continued, he unearthed this unique and strange, beautiful music. For example, in his album A Love Supreme, I don't know if you've heard it, but it's an extraordinary jazz classic. It has very few chords in it, but a lot of really incredible musicianship. And what he tends to do is take a very small idea and transform it in multiple ways. For example, this is the 035 or 37B set of notes. You can see it on the top left there. In C, it's C, E flat, F. It's this lovely little bluesy phrase, this seed phrase. And this passage, you can hear him manipulating it in many different ways. really just one phrase in many ways. And how he's changing it primarily is in terms of chromatic transposition, how high it is, where it's placed in the bar, and how stretchy it is. Sometimes they're long, sometimes they're short. So rather than thinking of this music as a flat page, we have 3 dimensions to deal with. We can think of each of those phrases as either being high, short, and on beat 1, or another parameter changing. In fact, they exist really beautifully if you present them on a cube with those dimensions. And so what Coltrane is doing is picking from these possibilities, this space of musical possibilities, and finding his trajectory through it. So his solo actually looks like this. No, I don't have many friends. So this is his entire solo played out on here. And I can even show it visually. Those are 3 of the phrases, and let's hear it on solo as it flies through musical space. And what's really beautiful, I find, about this vision is that it doesn't show music as one concrete realization, but a space of opportunity from which many melodies can be drawn. And it's very similar, and it looks exactly like, if there are any biologists here, what's called morphospace. This is what's called Raupp's cube, and it's all the possible seashells. Seashells also have 3 genes, which shape its various characteristics of verve, spire, and flare. So in fact, all the possible seashells are represented on this cube. And the gray area here, the shaded area, is the ones that are found in nature. So it's like nature has selected these, but there are others available, just like there were others available for Coltrane in his next solo. This lecture series was called The Nature of Music, How Music Works. But this viewpoint is more like there is a natural music that we can tap into. There's a music of nature that's always there. And this is a very positive idea that there is a huge possibilities that we can draw upon. And so musical pieces are structures within this field of possibilities, these shapes that occur. Let's take this one here. And this is a solo by Jimmy Smith, the blues organist. I don't need to explain much, but each of these bubbles small bubbles is a phrase, but you'll hear that they're related together within various fields. And as he solos, you will experience a sense of musical journey and understand his thinking, perhaps. And so music can be seen as just occasional realizations of this huge field of possibilities. What does this field of possibilities look like? Well, there's been attempts to try and map it out. Damien Riehl, who's a musician and technologist, attempted to catalog using very simple criteria of pitch, class, and rhythm, every melody that could possibly exist. You can even download it from this link here. It's 6 terabytes. There's 68.7 billion melodies. His reasoning is to protect artists from being sued for accidentally coming across something that appeared before them. And it's an interesting and perhaps noble idea, but it doesn't, at least to me, represent music. Melody is a very narrow way of thinking about music, and I'll demonstrate it here. For example, one of these billions of melodies would probably look something like this. I'll play it to you in the way that it's been catalogued. But that's not music. The actual music has harmony, timbre, dynamic control, and all the rich noise that makes up human expression. A little more. You get the idea. How can we capture that? That's what we're interested in, that deep music. And what is useful here is to borrow from literature. A short story by, I'll do my best here, Jorge Luis Borges. That's as good as you're going to get. It's called The Library of Babel, a 1941 short story. I don't know if anyone's read it here. But it imagines this universe, which is just made up of this vast library. And this library is just filled with books that are 410 pages longer. And every book has a permutation, and every permutation of a small character set. So there's every possible 410-page book in this vast library. And it's a really beautiful piece of literature. There are these people who are looking for the one book that explains why the library was written. But amongst it are all these great works of literature, a lot of gibberish, and then great arguments against those sacred books. And so it's about human knowledge and also the extent of human authorship. And as you read the short story, you get this eerie realization that the book you're reading is just one in that library itself. How does this relate to music? What are the letters, the alphabet of music? I don't think they're melody, but they're the sound canvas itself. And we can go to some way by thinking about digital audio. All sound is a waveform. And we can split that up into numbers. We can pick our resolution. Let's go with CD quality. That means if we think of a piece of music lasts up to 74 minutes, so that we could fit on Beethoven's Ninth, and has this bit rate and this sample rate, it has 5.2 billion bits within it. So our musical library of Babel would have every combination of zeros and ones. From all zeros, 5.2 billion of them, to all ones. That's 2 to the 5.2 billion combinations. Let's call that number a miltillion. Now, it's hard to imagine how big this number is. I'm going to do my best to explain it to you. But just a word of warning from Chris Lintott, permutations always win. So it's bigger than you think and could possibly think. But I'm going to do my best to explain to you how big this number is and the amount of possible music, at least in sonic form. So now let's think of each of those pieces of music, 74 minutes, not as the CDs. CDs, by the way, was something that we used to store music on. Never mind. Ask your grandparents. But we'll store them on a grain of sand, so that each piece of music is a grain of sand. And so I'll try and explain how big this library is. And we'll start here. So imagine yourself on a beach. And you pick up a grain of sand, and that is, let's say, Beethoven's Ninth Symphony. Pick up another, and that is Kind of Blue, or Madness's first album, or Bartok's Field recording. Everything that you hear in your lifetime can fit in 2 handfuls. Spotify is a bucket, and probably all of human recorded music fits in a few sandcastles, maybe a small beach, if we're generous. But that's not the extent of the library. The library would actually coat the entire surface of Earth and expand upwards, including not just the recorded sounds, but all sounds that have been made, from dinosaur roars to your best arguments. The library extends to the top of Everest and out to the stratosphere, engulfing all the radio signals that were broadcast out. It reached the moon and include every sound that we've made, including a child's voice bouncing off the surface of the moon. It would expand outwards and catch up to the Voyager space probe, traveling with its strange Earth sounds. But that wouldn't be enough. We'd have to head out into interstellar space to include all the music that hasn't been made, perhaps trapped in Ravel's mind, or a lost jam of Hendrix or Chopin's improvisation. It would include strange, every imaginable piece of music and an unimaginable one, but still would continue until we reached right to the edge of the observable universe. And it would include noise and also, without prejudice, every piece of human expression. But the universe would not be enough, so we have to be creative now. Let's go back to our beach. And now a grain of sand is a universe of music that we just filled. We'd fill up one, then a handful, then a bucket, then a sandcastle, then a beach, then the world of universes of music. Like I said, permutations always win. And we'd expand outwards. Everything you can imagine now, Kermit the Frog singing Nessun Dorma in every key, is in this vast library. It would fill up, and then we'd have to go a level deeper. Meta universes, filling up handfuls and buckets and universes, not hundreds of times, not thousands, but millions of times before we reached the limit of sonic authorship. I'm not sure what's more dazzling idea, the idea of how vast this library is, but also that it actually ends. The extent of human imagination, every music that's been made and will be made is in this vast library. Now we could argue about fidelity and what is noise and what is music and what's the same, but I'd like to think that even if the tiniest sliver of this is meaningful music, then we have a practical alternative of music to discover and enjoy. And to this vast library, I humbly submit these 6 lectures in audio form, just 6 grains of sand among that vast library. They live there already. But music is more than sound. It bonds us across cultures and even time and speaks to the depths of our logical soul in ways that are surely without limit. Thank you so much. Thank you so much. Thank you. Jeremy on sound, Tamsin on lights. Thank you to Gresham. Thank you. Thank you so much. Thank you so much. Thank you so much.
For the whole round I wish I could share all the love.
We've got time.
Yeah, but I'm going to go straight to John Coltrane and his Circle. I love that album.
Oh, Love Supreme, yeah.
And it just struck me as amazing that someone who I'd always thought was making the stuff up as he went along, creating sound out of sound, as you sort of implied at the end.
Yeah.
And yet there's a mechanical element to it, which I hadn't expected.
There's this sense that mechanics are the enemy of soul, and I don't feel that's the case. In fact, all the great revolutions were about ideas, this intersection of, let's say, science and art, but I just think it's craft, really. And we tend to think, maybe it's convenient to think that these great artists were somehow unschooled or didn't know what they were doing. Firstly, musical knowledge is not just about naming things, it's about knowing how to do things and repeating them. But the society of Hendrix, for example, was fascinated by music theory, wanted to study classical music, but he died too young, unfortunately. And Charlie Parker carried around Stravinsky scores to work from, and Coltrane's Thesaurus and so on. They knew about music deeply, sometimes with names that often aren't shared, but yes, it's always known at various levels.
Somebody online has asked, so do you feel, what they're asking is, have we approached a dead end? You answered it partly in your last question, but the idea of, the last statement of your lecture, but the idea of cataloguing everything somehow seems almost too rigid a structure for something that is as loose or creative as
the
music.
message here is like, it's beyond the ability to catalogue, but actually there is, let's say, a danger. There is a tendency that we like the familiar. We like some new things, but generally our musical enjoyment is rewarded by familiar things. So if we still keep listening to the same type of music, we do become quite insular and tend to enjoy that type of music. And you can see that happening in various subcultures of music. And the way of breaking out of that, I suggest, just like it would be for any genetic closing in of material, is cross-pollination. I invite people to listen to all types of music from all eras and to make all types of music, stuff that they don't initially like, because a lot of music is acquired and cultured taste, but a good taste, rewarding taste once earned.
Well, that deep mutation of the bottom note on the heavy metal that you
That's right. I enjoyed it all along that spectrum. I hope you did also.
Is there any music that's inspiring you at the moment which kind of points towards the future?
So there's some wonderful things happening at the intersection of electronics and, let's say, classical music. I don't know how to define it, but there is a sort of post-stylistic thing that's happening. And I really enjoy electronic music that engages with the virtuosity and expression that comes with the classical or chamber type music. And that's happening, I mean, I don't want to name too many things, but I mean, for example, John Hopkins has this approach to electronic music which doesn't seem to be rigid in terms of structure and meter and key. There's a guy called John Metcalf, they're not all Johns, I promise, who has this really delicate type of chamber electronic music. But I mean, I'm discovering stuff from the past, really. That's the, it's false to think that progression it's a non-linear universe we're living in, and you kind of think that there's this dissonance contour that happens in terms of harmony, but you listen to Renaissance, Gesualdo at the moment is blowing my mind with the sort of harmonic approaches he's using. So music is so rich that I don't think that where we happen to be in time is in a way, the pinnacle of it. It's like a garden that's flowering in different directions. But I'm deep into Ravel at the moment. I just can't believe how beautiful it is. And there's so much potential in what you can do with that and its crossover with jazz and electronic. So somewhere, to answer your question in some way, somewhere between what we might call classical jazz and electronic music, there's this beautiful thing that's happening that breaks away from the score. I'm into micro-timing and micro-tuning in an expressive way, not in a prescriptive way, and I think there's so much to be done there.
Thank you. We have 2 questions here in the front. In fact, 3. That's a cluster. Well, there's probably some triad that you should...
Oh, yeah.
Hey, Milton. Wonderful as ever. Wonderful
so
lecture.
much.
There's a quote that's always fascinated me. It's off a John McLaughlin album, Mahavishnu album, and he says, "This album is dedicated to the spirit of music that speaks the unspeakable." Would you agree with that one?
That's beautiful. I mean,
It's beautiful,
that's really.
isn't
I mean, I'm quite a skeptic, and if people know me, that it's hard for me to use words like soul and transcendence that means anything. But it's hard to put in other terms that it's a way. The Euler's term, I think it was him that talks about the logic of the soul, and that's what it is, that bypasses the symbolic meaning of language. Sometimes it uses it also. And I think that's the endless fascination with music. I mean, I couldn't believe, when I was 8 years old, I heard a few pieces of music, but it was basically the Beatles I heard. And I couldn't believe how they knew what was going on in my brain by manipulating sound. I didn't know how they did that, and I still don't. But that's brought me here, is this endless idea. And I don't think that at any point of answering those questions do you lose anything. You don't unweave the rainbow, you just discover more colors between them.
Yeah, thanks.
Yes, sir.
Thank you for your lecture. I was surprised to hear Bach's canon sound incredibly avant-garde.
It's crazy. I mean, he's crazy. In lecture 2 of next year, it's dedicated wholly to Bach's invention, and you will hear things, more things that will surprise you. But it's deeply chromatic and inventive. There's this idea that it's somehow stiff or structured. It's playful and imaginative and bizarre and wonderful. And there's, again, I don't think I've heard everything that Bach's made, so I should carry on with that. But it's quite sad we don't have enough.
They never play it on the radio.
They never play that one,
so
no.
avant-garde.
Well, that's another thing. It was one of the slides I didn't use, but if you looked at the Classic FM broadcasting, it's a real shame because there's such incredible music that is accessible, but somehow familiarity breeds repetition. And I think that's something that we have to actively fight against. I don't mean we have to sort of challenge ourselves all the time, but there's so many Ravel pieces that are just so beautiful that aren't played, even within the general great composers' oeuvre. I think that we can broadcast and embrace more. And it's down to us, really, as listeners to do that.
I think that's related to the way, the current wave of algorithms, which are re-suggesting what you like, are
really
limiting our hearing.
Point. Yeah, I think I'm a technophile, but I think it's really unfortunate politically, educationally, culturally, that we've built a model which gives us what it thinks we want. We don't know what we want. I didn't know I'd like jazz. I didn't know I'd like Ravel. I didn't know I'd be here. I quite liked it when it was the BBC and I was curated stuff, rather than me having to decide that I want to watch a crime thriller. I don't want to watch a crime thriller, but I just do it because I do it. It's a habit. And I think that's one thing of human behavior that we should do, and sort of break our sleepy habits. And I think algorithms could work. I thought this idea that you could have an algorithm that suggests something that's distant to what you like, just curated, not too far, but the right throw of distance, saying, well, you like that. I can tell that you like subdominant minor chords. So here's something that you've never heard that does that. So I'm very optimistic about what algorithms will do. But at the moment, there are poorly used Pandora's box, I believe.
So you had a question in the front as well.
Thank you. I just want to say your visualizations are incredible.
Oh, thank you.
And you actually just answered my first of my two questions, so thank you. The second was, I wanted to know what your thoughts were on the relevance of non-sonic information when it comes to music. So for example, I think particularly when we think about what it means for artificial intelligence to be creating sounds or music, about, for example, the embodiedness of the making of music, even if you're making it electronically, and how that impacts what you can consider as sort of an object of music.
Yeah, it's just a brilliant question, and it's something I just slipped in at the end there, in the last couple of sentences, saying that music is not even this sonic library. Again, we have this tendency to think of music as objects that we own and we have, and somehow they benefit us. But music is an activity, and some of the most musically rewarding moments I've had is not necessarily listening to Bach or the perfect rendition, but a moment with a friend or a colleague or a student where something magical happens. And of course, the musical experience is ritualistic, it's embodied, it's visual, and open to people who can't hear, as we know with many exemplars of that point. So it's a language and an activity that is multifaceted and indeed goes well beyond sonic information. But I had to start somewhere.
Yes, Professor, just to build on that question, have you given much thought to evolutionary biology and evolutionary psychology explanations as to why our auditory senses, this sort of harmonic processing, is so powerful in us compared with, say, our sense of touch?
Yeah, it's a incredibly insightful question because it's extraordinary, our hearing.
Yeah,
but
it doesn't seem to. It doesn't. I would be quite happy to switch off the visual field, but never, never, never lose my sense of sound.
Well, for a start, sound is an extraordinary superpower. It's continuous, and the decoding resources that we're using are immense. I mean, even for you to recognize the different vowels I'm saying is an incredible process that's happening in your mind in real time, and to put them together and to separate it from the other sounds here. In my first lecture, I went into this idea of how we make sense of this sonic canvas. But language and music seem to be driven together. For you to recognize what I'm saying are the same faculties that allow you to hear melodies and chords. And we do this ability to group. We can hear that there's a group of people, but one person talking within it. The same, we can hear one note within a chord. So this ability to draw sets around objects that we hear in real time in this fast, invisible bubble, it's just madness. And all the arts are incredible, but there is something about how music bonds with time that it's just so direct, and you can shut your eyes, but you can't really shut your ears. It's this constant stream of information that our brains are kind of molded around. And whether music or language came first, or whether they coexist, which I kind of think they do, is an open question.
May I press that point? I often think that people like Nimchimsky, who are trying to explain the origins of formal language, they are perhaps missing the point that I'm willing to bet we're able to communicate extremely fluently, pre-formal linguistically, using our powers of vocalization, and despite what I said before, then also our ability to be visually dynamic with our bodies. Now, do you think that, this is of course an impossible to answer question, do you think that there was much limitation on what we were able to conceptualize and communicate prior to the emergence of what we might call formal folk languages? I'm inclined to think that's not true. As soon as we had the resources of harmonic analysis, we basically had our conceptual world.
Okay, these questions are ramping up, but but essentially, once we have the ability to unpick the sonic canvas, so much is possible. That's to recognize sound objects among other ones, and also it couples with our need to predict. Music feasts on our predictive faculties, not just our recognition of sounds. It does both, in fact. And so in lecture 2, I went deep into the predictive frameworks that we use, both on rhythmic and melodic sequences. And the reason music is so rich is that it's doing all of this at once. We're recognizing sounds, words, picking apart colors, making sense of it, and predicting what's going to happen next, and this happening next in this continuous cycle. It's just ridiculous, which is not a very eloquent way, but it shouldn't happen, but it has.
I think that's bang on the money. Unlike our visual perspective, it seems to be intuitively from an origin. We don't appear to have this sense of single perspective on moments in sound. There appears to be an incredibly broad, what you might call Buddhistically, conception of now.
They're bound in this temporal ribbon.
I'm going to take the privilege of the last question here because we've run out of time. And this is a personal question from online somewhere. You said before you don't have synesthesia, but you do seem to, not just to hear music, but to feel it or see it almost mathematically. Do you see music differently to maybe most of us in this audience?
I think we all have an inner musical life. I think it changed. I remember as I went on to study music and listening to Bach, I'd close my eyes and I would see lines happening. I don't think I'm synesthetic, but I think in order for us to understand music, we do understand it in terms of physical movement, into visual imagery. I was very late to note reading, and maybe that gave me a different perspective on how to understand music. But any musician, they sit at the piano and we see this line, but what is under the surface and what we sort of know and what's so surprising is that there are all these loops that happen between all these notes. It's not this neat line. And we cope with that in different ways because it is coping. We cope with that in visual or just by feeling. And feeling is not thinking. It's a sort of soulful logic that happens that helps us unpick the immense but beautiful complexity.
Thank you, Milton. Ladies and gentlemen, please thank Milton once again.
Thank you so much.